Hello, this is Mr. Collier, and today we're finding missing angle measures using trigonometry. Okay, so we can also use trigonometry to find missing angles rather than just missing sides. And firstly, we need to remember our angle ratios. So we have to remember SOHCAHTOA. Okay, SOHCAHTOA, which tells us what the ratios are for sine, cosine, and tangent. So if we look at this triangle here, this right triangle, we're going to find the missing angle measurement theta. So this is the reference angle we're talking about. And let's go ahead and label the sides in this triangle. So in this triangle, this is the hypotenuse, of course, because it's opposite the right angle. And with reference to theta, the opposite side is the side on the opposite part of theta. So that's going to be the opposite side, and the last one here is going to be the adjacent side. Okay, so in this triangle, we're dealing with the opposite and the hypotenuse. So that's the ratio we want to use, which is going to be the sine ratio, because the sine ratio equals opposite out of hypotenuse. So we're going to set up the equation sine theta equals opposite divided by hypotenuse. And I'm going to fill in the numbers now. So the opposite is 4 centimeters and the hypotenuse is 15 centimeters. Okay? So the way we find theta here is, well, we have sine theta equals 4 over 15, so we want to reverse that to find theta. And the inverse function of sine theta is a function called inverse sine, or also called arc sine. This button should be on your calculator. So if you do inverse sine of 4 out of 15, you will get an answer for the angle measurement theta. So we're going to do that on our calculator. We're going to do second on this particular calculator. I need to do second function sine, and then I get sine to the power negative 1, which means not actually to the power negative 1, but it means inverse sine of 4 out of 15. So I'm going to work that out now. Inverse sine of 4 to 15, and I get an answer of about 15.5 degrees. That makes sense. That angle looks about 15. What was the measurement again? 15.5 degrees. Alright, so theta is approximately equal to 15.5 degrees. So the procedure is very similar to finding missing side lengths, but we're going to use the inverse trigonometric functions. Okay, in the next triangle, again we need to remember our SOHCAHTOA. And let's label the sides in this triangle. So we're talking about theta here. So opposite the right angle, we're going to have the hypotenuse. And with reference to theta, 12 is the opposite. And of course this one would have to be the adjacent. So we're looking at a ratio that uses opposite and adjacent, and that's going to be tangent uses opposite and adjacent. So tan of our angle equals opposite divided by adjacent. Okay, so that's our ratio. Let's fill in the numbers here. And opposite is 12, adjacent is 10, and to get the angle theta, we have to do inverse tan of the fraction 12 out of 10. So let's go ahead and use our calculator to do that. So I'm going to type second function, tangent, and then 12 divided by 10 in these brackets here equals, and we get about 50.2 degrees. So theta approximately equals 50.2 degrees. Alright, on to another example. Okay, this example it says solve the triangle. Okay, and that's just another way of saying find all the missing sides and missing angles. So we have all the tools now to do this. All you need in any triangle is 2 pieces, or any right triangle is you need 2 pieces of information. You can find all the missing sides and all the missing angles. So firstly, let me find the angles. I could call these angles theta, or maybe I'll just call this angle x and this angle y. And we're going to go ahead and find the angle x and the angle y. So if I look at x here, so let's be very careful. This is x, so we're going to start off with x. And so this, according to this angle x, the hypotenuse is going to be 7, of course. And with reference to x, this side is opposite. And the 4 is the adjacent. Okay, so we're looking for something with adjacent and hypotenuse. So let's check out SOHCAHTOA. SOHCAHTOA. Which one uses adjacent hypotenuse? That is cosine. So to get x, I'm going to do cosine x equals adjacent divided by hypotenuse, which is 4 out of 7. So x equals inverse cosine of 4 out of 7. And I'm going to go ahead and get that angle measurement now. So I'm going to do inverse cosine 4 divided by 7 equals 50, about 50.2, around 50.2. So that is 50.2 degrees. Okay. Now to get y, we could set up a trigonometric ratio. With reference to y, 4 would actually be opposite and hypotenuse. We'd have to use sine to find y. But actually we don't need to, because this angle over here is 90 degrees. So that means there's 90 degrees left for the other two angles. So to get y, we could just do y equals 90 degrees minus 50.2. Or on your calculator, if you've got this answer here already, I can do 90 minus, and second function, answer. So 90 minus, this will give me 90 minus 55.1, or 55.2, which I have there, which gives me this answer. And I just noticed a mistake I had here. This was 55.2. So let me go ahead and fix that error as well. That was 55.2. So let me go back and fix that. That was 55.2, 55.2, and when I subtract it, I get 34.8. So y equals, I should use approximately equal to 34.8, because this is a rounded number anyway, so this is also rounded as 34.8. So I've got two of my missing angles right now. I found my angles. You can get one with a trig or an inverse trig function. You can get the other one by subtracting from 90. Now I need to find my other side length. Okay, let me call that z over here or something. So z is the side length that is missing. Okay, I guess you could use trigonometry to find z, but since we have an exact value for each of the other two sides, I would use the Pythagorean Theorem. So we can just use the Pythagorean Theorem to find z. Z is not the hypotenuse, so z squared plus 4 squared, that's a 4, should equal 7 squared, because 7 is the hypotenuse. So I'm going to work that out. Z squared plus 16 equals 49, and then subtract 16 from both sides. We get z squared equals 33, and z equals root 33. Okay, in some instances, this might be acceptable for your final answer, but if you need a decimal answer, we can just do that with our calculator. And on this particular calculator, on this second function there, and that's square root of 33, which equals about 5.7. So that's about 5.7 if you want the decimal answer. Okay, so that's how you solve a triangle. And I've got one more example here. So in this triangle, we're finding theta. Okay, this is the hypotenuse. This is going to be the opposite. Okay, and the other one's going to be the adjacent. But we have opposite and hypotenuse, so that means we're going to need, let's see, SOHCAHTOA. Which one uses opposite and hypotenuse? That's sine. So we're going to have sine theta equals 4 out of 8, okay, which equals half. We can simplify that. So theta is going to be equal to inverse sine of half. Okay, so let's see what happens when we do inverse sine of half. I'm going to do second function, inverse sine, half. I can even type in 0.5 here. And look at that. I don't get a big long decimal. I don't get an irrational number. I get exactly 30 degrees. So I don't even need a squiggly equal sign. It's exactly 30 degrees. Which makes sense because there's another way we can do this problem. If you recognize the ratio here, we have 4 to 8 is the ratio of the side of the triangle to the hypotenuse. And when we have that ratio, you might remember that is the same ratio we have from a 30, 60, 90 triangle. In a 30, 60, 90 triangle, you have the ratio of 1 to 2 to root 3. Okay, so this side over here is going to be 4 root 3. So if you have a side of a triangle is half, or a side of a right triangle is half the distance of the hypotenuse, if you have this ratio of 1 to 2, like here we have 4 to 8, which is equal to 1 to 2. If you have that ratio, then we know it's a 30, 60, 90 triangle. And this has to be 30, and this one has to be 60. So you didn't actually need trig to solve that problem. But if you did use the inverse sine, you do get exactly 30 degrees, which is the same answer you get either way.